All right, so here we're just trying to remind you that you can cancel things. If there's one on the top and one on the bottom, you can cancel them. And so I can cancel these two. And when I cancel them, they really become ones. And so it's really y equals 1 over 1, which is equal to 1. So y equals 1. So if I graph that, y equals 1, it just looks like this red line here. Y equals 1. But this is actually wrong. There's something more to it. And I mentioned it earlier. Holes. What do you think is wrong with my graph? Yeah, there needs to be a hole. And where should it be? What's the one thing that would mess this graph up, or this equation up? -3. That's why we've been talking about domains so long, because -3 would mess it up. So at -3, you're supposed to have a hole. It can't really be anything right there. So I can't have a solid line. That implies that everything's fine. But at that right spot right there, it looks like this. It's a wholly function now. All right, so it's got a hole in the middle of it because at that particular spot, you can't have a value. All right. Let's see if you get this as we move on to a little harder ones. What's going to cancel here? What's that going to make? And at -3, you're going to have what? A hole. So it's the normal graph, y equals 1 over x, but there's a hole because of this thing. Because we're canceling it, we don't want to forget that we can't let x be -3. Or 0, you're right. But at 0, that's where the asymptote is going to be. The holes are where you cancel something on the top and the bottom. That creates a hole, which is different than an asymptote. Okay, so there's a hole at -3. So what would this look like? It would look like this. This is the parent function. And see the hole right here? That little white and red, the little white spot inside the red? That hole there is because at 3, we have an empty spot. You can get that? So it's the normal graph with a little hole, a little imperfection in it. Okay, this one. Is it done right? All right, well, let's look at it from this perspective. If I cancel this, that creates a hole, right? Where should the hole be? -3, so that part's okay. And y equals, when I'm done with this becomes a 1 and a 1. It becomes 1 over x plus 2. That's the parent one, except shifted where? What does that tell me? 2 to the left. Does this look like the parent one, except shifted 2 to the left? Yeah. And it's got a hole for this spot at -3 where it would mess it up. Right there, there's a hole there. So that's right. Okay, let's look at another one. Is this one right? No, the holes are in weird spots. That's not making any sense. So let's actually move it so it is right. All right, so let's cancel some stuff. You see how that cancels? See how that cancels? Creates 2 holes. One's at what? -3. One's at what? -4. Okay. And I should look at what my graph looks like in the first place. After all these things canceled, it should be y equals 1 over x. Isn't that the original? That's the parent one. So I'm going to move this to the parent spot. That's the normal. Hasn't been shifted at all. But there's 2 holes. One's at -3. One's at -4. Here's the hole at -3. Here's the hole at -4. Get that? So you just graph it like normal. And at the one spot where things canceled, make a hole in your graph, implying that there's no way to get that answer. Now, a lot of people, again, go, why isn't 0 making a hole there? Well, 0 is an important spot. You can't be 0. But remember, 0 is this. It's an asymptote. It'll never get there. It'll get closer and closer and never get there. And that's the difference. A hole is just a skip, like you skip that spot. Whereas an asymptote is something you will get. It's not just a spot you never touch. It's a spot you never touch, but you get closer and closer and closer and closer. Okay? So yeah, this is an important spot. 0 is an important spot, but it's not a hole. It's an asymptote. All right. Moving on. Sometimes you'll need to factor. Like if I take my equation right now, it doesn't look like there's a hole, but there will be. Why? Duncan. Yeah, it's not factored out. Yes, so factored for me. How about you can guess what one of the factors is? Right? It's got to be like that because otherwise we're talking about holes. So it's probably like that. So then x plus 3, and then what's this one? X minus 4. And that's what this one is factored. So that makes sense. So now that I see it that way, now I can see easily that there is a hole. And the hole is going to be at where? X equals negative 3. Now this one's a little weird though because once things cancel, it's y equals everything cancel except x minus 4. Now sometimes you guys that are so smart and you've gotten into really complicated graphs and you look at that and you go, I don't know how to graph that. Sure you do. It's really, really easy. How do you graph that? It's just a line. Where does it go through? Yep. So you start down there. That's got a slope of what? 1. So nice slope. Maybe that's a little too steep, but and then at negative 3, go down here and there should be an empty spot there. Okay, kind of cheated. Because the empty spot should be right in the middle of the line, but anyway. Okay, let's look at this one. How do I think I should start? Factor it. So if I factor it, I get x plus 2, x minus 2, and then x minus 2 on the bottom. See how it cancels, and that makes a what? A hole. And so it's y equals x plus 2, normal straight line, with a hole at x is what? 2. All right. What if they give you the graph and you have to write the equation? It's not that hard. If I was going to write, if I just look at this red line right here, and I asked you to write the equation for that, that's like, for you guys, that was in 7th grade. Piece of cake. Maybe even 6th grade. Y equals 2x plus 4. Why 2x? Because it's got a slope of 2. Rise 2, run 1. Remember that? Okay. So here's my equation, except it had a hole in it. Can't remember where the hole was. I'll just put it here. Maybe that is where it was. If I want to make that hole, I got to have my equation be a little different. I need to have something cancel. So you just make yourself a big fraction and put in something on the top and the bottom that cancels, right? And we needed a hole at negative 3, so it's x plus 3 and x plus 3. There's my equation for that line. Get that? All right, let's look at this one. This is a simpler one. It's y equals 1. Do you get that? But we need to add the hole in, and so I make it into a fraction, and I put something on the top and something on the bottom to make the hole. X minus 5 and x minus 5. That creates a hole right there. So there's my equation. All right, and let's pull it all together. So it's a lot of times today you have to factor. You're used to factoring. That's why we did factoring right before this. X minus 4. Ooh, that's ugly. And then x minus 4 and x plus 3. And then the x minus 4's cancel. Bing, bing. Creates what? A hole. Now, I should do this first. Y equals 1 over x plus 3 is my new answer. But I got to remember that there was a hole. Now I should look at my domain. Should I do my domain based on this or based on the original one? The original one. The original one had 2 things that would mess it up. I'm going to go back in time here a little bit. Oh, there. What are the 2 things that would mess that up? All real numbers except 4. X cannot be 4. And x cannot be negative 3. Okay, my vertical asymptotes. Remember the vertical thing is you can pull these over and make them like x's. And the horizontal, you can like rotate it around and make it like a y equals. Okay. All right. The vertical ones are the things down here. But remember how I said that it's not always going to be both? Well, it's x equals 4 and x equals negative 3. But one of those can't be an asymptote because it's the hole. That was the hole, and the hole was this one right here, so it can't be a vertical. It's got to be a horizontal. It's got to be a hole. All right, and then we'll do the horizontals. Bigger on bottom, bigger on top, same on both. This one is bigger on the bottom, and so it's a 0, y equals 0.